I'm James Johnston, Training and Support Manager at Microsurvey Software. I'd like to talk to you a bit about how StarNet is masterful when you're combining data from different sources. What I've got open here is a project that was generated for training purposes, and it's actually the end product of one of our online classes on combining data. And it's kind of the grand finale of all the different steps that the students have stepped through to process data from multiple sources. I'll just give you a little bit of a tour of it, just to help you to understand the capabilities of StarNet. So first of all, what I'll do is we'll view the Traverse data. And so what's happened is there are two files that were Traverse work that was done with robots, and it was just done on the building site here that you can see on the plot. And so these are now, because they're tied into GPS, these are now georeferenced, and whenever we run the adjustment, not only does StarNet act as a regular Traverse computation program to compute all the points, but it also allows you to use the most rigorous methods to compute that Traverse. So StarNet will compute a appropriate scale factor for every measured distance. It will compute a t minus t correction for every angle, considering the distance from the central meridian of the system. And so what you get is a Traverse program that can be used over much greater distances. So that's one way in which Traverse data is handled. Another important thing to note is in this project, we're actually using just a single instrument. So we've defined our standard errors with a single instrument, but there are many cases in larger projects where multiple instruments with different specifications might be used. And StarNet has a wonderful tool called Instrument Library that would actually allow you to assign a name for each of the various instruments. So this even allows you to mix instruments from different manufacturers. So that's how StarNet would process your Traverse data. We also have in here, we've got some RTK vectors, and in this case, they came from one manufacturer, and they actually have a different weighting than do the post-process vectors that I'm showing in another sample. So what we're using here is an inline option. That's another very useful tool in StarNet that makes combining data much simpler. So I've just typed in a little line of code here that tells StarNet to loosen up our expectations for, in this case, the horizontal and for the vertical separately in order to make that RTK data fit properly with the post-process data, which is a little bit higher precision. And then I can go into these long post-processed vectors, and these vectors, when we back up our file here, if you zoom back, they actually tie into 3 different NGS cores stations in the overall project, and so they're much longer but also quite high precision. So what they do is they allow you to assign an orientation and a location for your project that gives it a strong degree of accuracy. And GPS vectors are always weighted against the covariance matrix information that is reported by the software that was used to either post-process it or to process the RTK information for RTK data. So what we managed to do here so far is tie into some stations and generate a good location for our building site, and then use Traverse data to tighten up the internal accuracy right in here on the building site. So we've got both precision and we've got accuracy. And then a final step that was followed in this project is that leveling data was concerned. Very often what will happen when there's precise leveling as part of a construction project is it's desired that the leveling data become the absolute authority for elevations. StarNet does have the ability for you to process leveling data along with other types of data, but the preferred method is what I'm doing here. So I'll highlight one more file. This file here, you'll notice how it has a different extension from the other input files. It's a PTS file, and it's actually the output from a different StarNet project in which just the elevations were computed from leveling. And an option was turned on to just make them output as fixed elevation records. And so these final elevations are in essence being input as a constrained elevation for the stations that the other types of observations touch onto. And this is an ability StarNet has that I notice makes a lot of people smile. It does solve a lot of problems. So that's the end of the lesson, and the students went through many steps in order to troubleshoot and make this all fit together. And when it's all done, I just run the adjustment, and I'm satisfied with the results. And as a final stage, what you can do is you can output a simple ASCII file, which is automatically generated as I run the adjustment. There's an option to output latitudes and longitudes if you so desire. There's an option to output what's called a ground file, and so what that would be is a transformed file that could be customized to, for example, the local system of a construction site. So you can shift it, you can shift your coordinates, you can rotate your coordinates, and you can scale them to ground if you wish. Very often that's a popular option. The last thing I'd like to do is output this as a KML file, and let's have a look at what it looks like in Google Earth. Or you can bring it over, and what you'll actually notice is this was work that was done around Washington, D.C., and there are our core stations, and we can zoom right in on the highways yard where the main work was done. There. Thank you for letting me show you a few of the really cool things you can do with StarNet and the enormous flexibility that you get from having a dedicated least squares adjustment program that allows you to work with data from all manufacturers, from a wide variety of instruments, and from a wide variety of sensor types.